Hello everyone, welcome back. So in this video today we're going to talk a little bit more about exception handling because we know it's really important in Java. So we're going to do a little bit of the previous stuff and then integrate some stuff to explain it. So it's just a deeper look. So I've written out a program here, import java.util.scanner. We haven't looked at scanner for a while, so we're coming back to it again. The java.util package and the scanner then class within that package. I've created a new class then, divide by zero no exception it's called. As you can see, it always matches the Java file, just to keep reminding you of these things along the way. And created a new method, and it's a static method, and we should know already what a static method is because there's only one and it's shared then across it. So here we have public static int, so it returns an integer. It's called quotient, and then int numerator, int denominator, so fractions basically. So here then we have our main entry point and our string array as usual, capital S because it's a reference type, and we have our input. We can also call this scanner if you wanted. We can easily change it by refactoring and renaming and then calling it scanner, and that renames it in all the places that it's used as well. So once I highlight it, you can see that it's used in other places. It takes the input from the input stream, and it just prints out. Firstly, we're going to print out our system out.print with our question. So please enter an integer numerator. Then we assign the next int to numerator, our next one then to denominator, and then we pass those through to the method and assign the result to an integer called result. I can easily call this if I wanted to. I can call this if I refactor it, just to make it clear. Numerator. So you can see that it's only being renamed here for this method, and this will only be renamed for this method. And so if I right click and go rename denom enter. So now when these are passed through, the same as what you do in mathematics when you plug in something to go with x and y, this is plugging in the values for numerator from the screen, numerator and the denominator, and passing it through the method to do the calculation, which is up here, which is the division, and assigning it to result, and then printing it out on the screen. Same as usual with the placeholders. So %n for new line, %d for integer. If it was a double, it would be %f. Then the precision length is 6, but if we want it to be lower, then we'd specify the number before the f as well. Now, so this is, I'm going to firstly take out this because I'm going to talk about that in a second. So firstly, this is going to run, and I'm going to put in two numbers. So here we have 100 and then 14 and our result, and that's pretty straightforward. Now the next time I run it, if I run it again and I want to do 100 and then 0, and now an exception has been thrown automatically. So within this there is the method called stack and the stack trace. So if you're unsure about the method called stack and everything like that, you should take a look at the data structures video where I explain it with a stack of plates and you push on and pop off each of them in the last in first out for method calls, and then the call chain then is within here. So when we're explaining it, we're looking at exception in thread main, so you can see where it's coming from. We'll talk about threads later on. They're two processes. And here it shows within the java.lang there's an arithmetic exception, and it tells you what lines they're on. So it tells you that it's the division by 0. It says it's here trying to do this and it also shows where it's coming from. So here in 17, you can also do, if I run it again, and let's say if I put in 100, and what would happen, let's say if I was to say divided by 7 and then have h in it, you can see that there's a java.util input mismatch because it's only expecting an integer. So it will tell you here within the call chain that it's a throw for this line within scanner, this line within scanner, this line within scanner, this line within scanner, but actually within our own code it's in on line 15. So if I go to line 15, then you can see here that it's expecting an integer because of the next int. So it's pretty straightforward. We can talk about a little bit more about this later on, but for now it's just good to get a grasp on it. Here as well, I can also run it again, and you can always call what's called a thread.dumpStack to show on screen as well. And if I just make it run as normal, so it will show you that it's calling a stack trace, and it shows the java.lang exception. Now within this as well, we can easily import then what we just saw a minute ago. So no spaces, java.util. And then we can use the mismatch. So if I say input, come on, no, not going to let me input. There it is. And so there's input mismatch exception. So it's not been used yet, so it's going to give me an error. So now I'm going to create a couple of exceptions. So I'm going to say throws here, and then I move that across and say arithmetic exception. So this then, if I highlight over it, it shows where it's coming from. It's coming from the java.lang arithmetic exception. So it's really important to get to know kind of the packages within Java and understand that you can look them up online in the Oracle database. You can figure out what they're doing. You can even look up the code yourself and what package it's in. All you have to do is go click on it and go straight to the arithmetic exception class, and you can read everything to do with it. Here we have the throwing the exception, and here we want to put in a boolean to see whether we're going to put another input, and then we're going to put this chunk of code into a do while loop. So if I have boolean, which is a primitive type, continue loop, and as we know with booleans and the primitive types, that default is set to, comment below for what it's set to. So the default is really important with these because you'll see at the start of the program if it's not declared, so declare assign use, if it's not declared at the start of the program, then it will use the default first. So we are going to use it as true first. Oh, and I'm going to comment on it this time. More input is needed. Perfect. So this is our continue. So we have a do, open bracket. It's a little bit tricky with the do while loops because we want to keep all of the things together. And we have what's called a try catch block. So we're going to have a catch, a try here, and then this is in the wrong place. But we're going to move this all up. I'm going to remove this. I'm going to move this code all up here into the try. Ta-da! And then we're going to have a catch. Oh, I'm going to have to say continue, set the continue loop variable to false. The trues and falses are really nice to do as well, because when we have the true and falses, we can use what's called a finite state machine. I'm going to introduce more vocabulary as I'm going as well, as usual. So when you have it set to on or off, basically it works the same way. So we have our input mismatch. Let's see how it's spelled above. Oh, smaller m, really important, otherwise it's a different thing altogether. So I might actually just copy it and put it down here like this. And then make it smaller because we're making one, and we are going to now have something in our catch, which we have to line up each of our now here's what's interesting about Java is that we can have our print statements as well. So here we have our printf, which is expecting our local variables. So we're going to have our exception. I'm going to make a new line first, exception, and a string to go in here, and another new line. So %s for string as usual. And oh, just for readability, let me move that across. I'm going to copy this down now, and I have my input mismatch exception. And then we can say scanner, oh, it's lowercase, scanner dot next line. Oh. Now, this is the other thing, is that we can copy a lot of this now and say, do we want just to ask the user for something or print out? So this is system.out, and we're just going to say, please enter more integers only. And I'm going to remove this part, and I'm going to also have to clean up a lot of my stuff. Now we have another catch block, so everything is in blocks of code, like paragraphs in a language. And this time we're going to have arithmetic, which is part of the java.lang, which we know from up here. So actually, if I copy this so I'm not spelling it wrong, and then copy it again, but with a lowercase this time, or we can call it whatever we want. And then we're going to copy pretty much this and put it down here, this and put it in here. And this is a little bit, yeah. Now we can say 0 is an invalid denominator. And we have a bracket here. Oh, another bracket, while, and we can have a continue loop. When the continue loop is true, then do all of this. So you can see all the colors now change because all the things match. So if I just click on this, I can see whether it matches the end of the file. It's really nice with the integrated development environments because it will show your matching brackets. So if I just hover over it, it shows you that it's the end of the class. So with that, then we can run it. Save first, run. And so if I have 100, again, 7, yay, run it again. So that little bit long way of doing it, but it works. 100 and then 0. And you can see the arithmetic exception system.out.print, or yeah, system.out.print F here that I have. And I've said arithmetic exception. 0 is an invalid denominator. And let me see that. Where does it say that? Here. 0 is an invalid denominator. So this is our error, and it's a print stream. So it's the standard error output stream. So you can assign what the error is going to do to show up. So you can see it's in red. It's an error. Please enter. And then it says division by 0 as the error. So you can do a lot of different things with this. If we say this, if we run it again with the same inputs from previously, so 100 and then 7 times, and you can see here, please enter integers only, and it allows you, basically it's allowing you to fall gently. So if I have, and then I can it easily allows me to run the program again. So if I do it again, and if I go 100, 0, please enter an integer number, 100, 7H. So it allows me to continually do this without exiting from the program. So the first time we did it, it just closed it. That was it. It fell, not so gently. So with things like fault tolerant systems, so normally in a computer science degree, you might learn about fault tolerant systems as a whole course. But a crash course is basically that if you're flying an airplane, if you get an error in one of the systems in the TACAS system, then you want it to fall gently. You don't want to just stop because there are lives at risk. So with fault tolerant systems, generally you have like two systems, or you have errors that catch different things, and you have basically security constraints put in place. Security not in the way that we were talking about with the truncated integers and the division by 0, but security as in for safety reasons if anything happens. So you might have multiple and in different locations, and there are certain rules with the servers being available. So if you have two servers within the same location, they have a higher risk of both falling over if the electricity goes. So it's better to have them in two different global locations, and then it's more fault tolerant. So it's tolerating more faults, if you think of it this way. So if you're thinking that there's a fault with it, so in this case it's got the division by 0, then it would just normally exit the program. We don't want to do that. So here as well we have our input mismatch. It would exit automatically. We don't want it to do that. So it would say keep going. You can keep doing this as long as you're and it will keep doing it and keep allowing inputs each time. So if I say 100, 0, and it will keep allowing me to enter something instead of it just closing. So that's it for today. I hope you liked the video. I'm going to put up a little bit more frequently. There might be a little bit pause more in videos. I want to know your feedback, and also please subscribe, because I need to know whether people are watching or not. And if they are, then obviously I'll upload more. If they're not, then I won't. So thanks for watching, and yeah, stay safe. Bye.